Hello, my name is Isabel Augustine. I am a junior chemistry major with an environmental chemistry concentration at Florida Southern College. For the research that I'm presenting today, I have been working with Dr. Deborah Bromfield Lee at the Florida Southern Chemistry, Biochemistry, and Physics Department. My research focuses on ways to make the organic chemistry teaching lab greener by looking at variations on experiments that touches on at least one of the 12 green chemistry principles. We started out by exploring ways to make a greener aldol condensation reaction. This reaction is often performed in the organic 2 lab as well as professionally because aldol condensations can yield chalcones, which are widely used in the medical field. Typically, aldol condensations are done in a solvent, but in an effort to prevent waste, I used a solvent-free procedure and have been working on how to make that procedure most efficient. The original method that I used involved adding a 1-to-1 mole ratio of 3,4-dimethoxy benzaldehyde and 1 indinone into a beaker, grinding the two together with a glass rod, adding sodium hydroxide, grinding more until the mixture solidifies, letting it stand, doing an acid workup to neutralize, and filtering out the solid. The variations on that procedure that I have already tried are using a mortar and pestle in place of a beaker and glass rod, which not only made the reaction easier to perform, but also made it more efficient. I have also used excess amounts of sodium hydroxide, meaning a greater than 1-to-1 mole ratio, which yielded a complete reaction and was very efficient. I've also used a sodium hydroxide aqueous solution, which worked, but not as well as using excess sodium hydroxide. And I've also used excess sodium bicarbonate, which is baking soda, in place of the sodium hydroxide, which did not appear to yield any reaction at all. Variations that I plan to look into in the future are using potassium carbonate in place of the sodium hydroxide, using a mono or microwave to heat the reaction, and varying the two starting materials with different substituents based on computational data in hopes of finding the most efficient starting materials. So ultimately, the most efficient procedure developed by this research will be used by students at Florida Southern in the organic chemistry labs. And so far, using excess sodium hydroxide with a mortar and pestle seems to be the most efficient procedure, but there are still plans to continue exploring different conditions further. So that is all I have today. So thank you for watching, and please feel free to leave any questions you have. Thanks.